My voice will hold out for making these videos. Let's get started with talking about object-oriented programming. And so we're going to talk about kind of my Greek myth view of object-oriented programming. And so besides this being kind of a Greekophile, we can look to the fact that Python was the name of the dragon killed by Apollo at Delphi. And so it's not unreasonable to look to the ancient Greeks for guidance to understand how we ought to be programming with Python. After killing Python, the snake, the dragon, Apollo built a temple at Delphi, and the temple was graced with two famous inscriptions: "Nothing in excess" and "Know thyself." And so these two inscriptions are going to guide us in our analysis of object-oriented programming. So let's start off with "Nothing in excess." So Python takes a pragmatic approach to object-oriented programming. So object-oriented programming is good for a lot of things. Traditionally, kind of really made early impact in computer graphics. However, for many scientific programs, traditional procedural programming may be a better fit. And with the rise of multi-core processors, etc., object-oriented programming, at least as implemented in Python, isn't always a good match. Python lets you write programs that best fit the nature of the problem. So we can write procedural code, we can write object-oriented code, we can write functional code. So classes can be used when needed, but we should try not to use them in excess. So the first thing we should think about is, for the task we want to do, is a built-in Python type sufficient? Can I just use a dictionary, or maybe a named tuple would be sufficient? And if not, maybe just a very simple class that inherits from one of these basic types. Okay, so that's the nothing in excess. We write object-oriented programs when we need to, not excessively. So know thyself. So my favorite definition of an object is that it is an entity that knows itself. And this comes from Mark Thomason, who was a PhD student with us, a graduate student. He finished with his master's in medical informatics years ago. So by knowing itself, the object knows how to do all the basic functions associated with it. So if we think about a list object, it knows how to print itself. There's a view of a list when we print something. We didn't have to define anything special for it. It knows how to insert an object into itself, either through an insert or an append. It knows how to sort its components, etc. So when we say that an object knows how to do something, we mean that it has a method, which is a type of function that is attached to that object. So it has a method that performs that function. Okay, so let's look at some other characteristics of object-oriented programming. So object-oriented programming demonstrates polymorphism, from the Greek having multiple forms, which allows us to write programs with similar form regardless of underlying representation and nature or differences of the object. So polymorphism enables you to call the methods of an object without knowing its class type of object. So we have a plus operator defined for strings, and we also have a plus operator defined for integers. If we call the length function, the length function doesn't care whether we have a list, a string, or a tuple. Another important concept of object-oriented programming is encapsulation. So encapsulation is the principle of hiding unnecessary details from the rest of the world. So if we do a good job of writing object-oriented code, then the user of that object doesn't need to know the internal representation and the internal details of the class. That can be hidden from them, and in fact, we should be able to change the underlying internal logic, and the user of the class or object wouldn't need to change change the program that's using that object. Inheritance. This is really where object-oriented becomes powerful, is we can recognize that there are groups of objects that have similar characteristics. And so we can define like a very primitive form of that class of objects. And then when we define a more uh, advanced version of the object, we can inherit, without needing to redefine it, the characteristics that were associated with the primitive version. So we define the characteristics for most of the general group, and then we inherit those general characteristics and we add details as we define inherited classes. So for example, we could define a primitive concept of a 2D shape. So a 2D shape has an area and a perimeter. If we inherit from that and define a circle class, well, the circle has a specialized idea of the perimeter, which we call a circumference. Or we could have a polygon, and the polygon adds a specific idea of like the number of vertices. And we'll go through examples of this where we look at people and patients in a minute. Okay, so as we've mentioned, there are a variety of programming paradigms. We don't have to write object-oriented programs, but everything in Python is an object. And we've been using that so far, although we haven't really explicitly explored it. And we'll skip that. We've said that multiple times. So when I say that all intrinsic types in Python are objects, that means that they have attributes and methods. And so from a book that I've used in the past for this course, Beginning Python, the author says, when you think of attributes, think of adjectives of the object. And when you think of methods, think of verbs that are associated with that object. So just to kind of show that everything is an object, even our most basic type, like an integer, is an object. And so if we create an object and then we look at the help for it, we'll see that these are the methods that are defined for an integer. There is this double underscore ABS, double underscore. That's the apps. This is a method that defines what is meant by an absolute value for an integer. This double underscore add double underscore tells us how to add two integers together, and bool, so on. Now the syntax of this double underscore, a function name double underscore, is going to be something that we're going to run across again and again in Python. And I don't know if it's an official term, but I think that Beginning Python book that I referenced above referred to these as magic methods. And so that's how I refer to them, as magic methods. And so Python defines this idea of a magic method that's the equal, so double underscore EQ double underscore. So if our object has this method defined, then when we do the double equals, we can define the concept of an equality comparison for our objects. The float would be how we would convert something to a float. And here are other comparison operators like a greater than or equal to, greater than, etc. So these are all methods that are defined for an integer, and these will be invoked when we use particular operators in Python, like the plus or the double equal or the comparison symbols like greater than, less than, etc. Okay, similarly, let me define a string, my name, and a string is an object. And so it's going to have a variety of these methods. So there's an add method. What do we mean when we take a string and two strings and we put a plus symbol in between them? There's a delete attribute. There's again an equality, a comparison, what do we mean by a greater than or equal to? A get item. This is how we're going to do indexing. That we can do the square brackets 3 get the fourth element of the string, for example. The iterator method is how we can loop over, iterate over the elements of a string. Less than is a length, etc. So even our, just kind of again emphasize that our most basic objects, types, integers, and strings, are all objects. They have attributes and they have these methods.